The components of our Q matrix are in fact matrices themselves. So in the matrix Q, we have various matrix entries. So Q00 is just a 1 by 1 matrix with entry minus lambda. Q01 is a 1 by 2 matrix with entries lambda 1, lambda 2, and lambda 1 plus lambda 2 sum to lambda. So if I put this minus lambda on the diagonal, the sum of the first row will be 0. The matrix Q10 is a 2 by 1 matrix that consists of entries mu1, mu2. The matrix Q11 is a 2 by 2 matrix. It has diagonal entries as we see here. And the matrix Q12 is a 2 by 3 matrix. And if we look at the entries here, Q10, Q11, Q12, we find that the rows will sum to 1. You have the mu1 and then a minus mu1. You have a minus lambda that goes together with a lambda 1 and a lambda 2, and so those will sum to 0. Similarly for the row that has a mu2 and a minus lambda plus mu2, lambda 1, lambda 2, the sum of that row will also be equal to 0. Similarly, we will get the Q21 entry. This is a 3 by 2 matrix. Q22, which will be a 3 by 3 matrix. And on the next page, we will have Q23, which will be a 3 by 3 matrix. And as before, the rows will all sum to 0. So let's move to the next page and look at the next set of entries. As indicated, Q32 is going to be a 3 by 3 matrix. It has a particular pattern. You can get the entries of Q32 by looking at the state transition diagram. Note that this represents a decrease. We're going from a system with 3 customers to a system with 2 customers. So these would represent the decreasing part in the state diagram. Note also that once we get to Q32, everything is going to repeat itself, going from Q4 to Q43, Q54, etc. Similarly, to go from 3 customers to 4 customers, that means we're having an increase. The increases are happening at rate lambda. Lambda is lambda 1 plus lambda 2. We don't distinguish between the short and long customers at this stage. We do that later. Q34 is going to repeat itself at Q45 and Q56. After we have Q32 and Q34, then we can find Q33, which is set up so that the rows will sum to 0. So if you have a lambda here and a 2 mu1 p and a 2 mu1 times 1 minus p, you sum all those, you get this lambda plus 2 mu1. You put a minus sign in front of it, so the rows sum to 0, and you get your result for Q33, the diagonal entry. Similarly, we get the other two diagonal entries of Q33. I would point out that here we have this A plus B plus C, which we had defined when we were talking about our state diagram. And if you look at the definitions of A plus B plus C and sum the three pieces, A plus B plus C, you find that that sums to mu1 plus mu2. So we could simplify our matrix a little bit if we chose to do so. So this is the pattern that will repeat itself along the diagonal. So now we get a patterned matrix for Q. It's tridiagonal in blocks.